in this problem, we're asked to compare aluminum to HCl, so we're going to need a balanced chemical equation. We can get the unbalanced chemical equation from looking at our question. It's clear that aluminum is reacting with HCl, and we're told that the products are aluminum trichloride and hydrogen gas. Now we need to balance the chemical equation. All right, our equation is now balanced. Okay, as we read the question, we see that we have an initial mass of aluminum and a final mass of aluminum. So we can determine the amount of aluminum that reacts via subtraction. We're asked to compare aluminum to hydrochloric acid. So we need to do this on a mole-to-mole basis using a balanced chemical equation. We have our balanced chemical equation, so we need to convert our mass of aluminum that reacted to the amount of HCl that was consumed. We set up our conversion factor such that our grams of aluminum cancel and we're left with moles of aluminum. Now that we know the moles of aluminum, we can use our balanced chemical equation and the coefficients associated with both aluminum and hydrochloric acid to set up a mole-to-mole ratio. So here's our mole-to-mole ratio. The 2 comes from the coefficient associated with aluminum. We know aluminum has to be in the denominator so that these values can cancel out. Now we know the moles of HCl that were consumed. What we want in an answer is a concentration of HCl. The final step is to calculate the concentration of HCl. So we want moles of HCl per liter of solution. We've just calculated the moles of HCl. I've kept a couple extra sig figs. I don't want to round until I get to the end of the problem. Now we go back to the statement of the problem. We see we are given the volume of the HCl solution. Okay, so we set up, this is our moles of HCl from the first part of the problem, and the liters of solution from the statement, and we look at our sig figs, and we can justify 3 sig figs, so this is our final answer.